This is the video for Unit 10, Lesson 1, Reciprocal Functions.
In this section, we have goals of identifying our 6 trigonometric ratios for a given angle. So we've already learned 3, sine, cosine, and tangent. Today we're going to look at the next 3, which are the reciprocal functions. And then we're also going to evaluate an angle using trigonometric ratios. So our reciprocal functions are really taking our original 3 functions of sine, cosine, and tangent, and just simply taking the reciprocal or flipping the fraction. So our 3 reciprocal functions are cosecant, which is your hypotenuse over your opposite, so that's going to be the reciprocal of sine. We have secant, which is hypotenuse over adjacent, so that's the reciprocal of cosine. And then the last one is cotangent. And that one is adjacent over opposite, which is the reciprocal of tangent. And this should only say one tangent right here. So when we look at this, you want to think about it almost as pairs. So if you know sine, cosine, and tangent, you just have to know the reciprocal. So sine goes with cosecant, cosine goes with secant, and tangent goes with cotangent.
This first example, we're going to find the 6 trig ratios for a given angle in a right triangle. And we're going to find that with these angles, we like to call the angle theta. That's just a Greek symbol that we're using to be a variable for a given angle. And like we saw previously in the last unit, we're going to have to first find all 3 sides to write the 6 trig ratios. So I don't know what this hypotenuse is. I'm going to call it r just for right now, or just some variable. And we're first going to do Pythagorean theorem to find what our third side is. So if I go ahead and solve this out, I'm going to get the square root of 10. And now we can approach it just like we did when we were writing our original 3 trig ratios. So I have my hypotenuse. If I was to trace the angle, I can now see my opposite leg and my adjacent leg. So 1 is my adjacent, 3 is my opposite. And now we're just going to simply write our different trig ratios. We still are going to use SOHCAHTOA. And we're going to write these out. So sine is opposite over hypotenuse, so I'd have 3 over root 10. And then cosecant is the reciprocal of sine. So if I was to flip it and take the reciprocal, that would be root 10 over 3. We're going to rationalize at the very end, because sometimes doing the reciprocal before rationalizing is a little easier. Cosine is adjacent over hypotenuse, so that's going to be 1 over radical 10. Secant is the reciprocal, so that's going to be root 10 over 1, which is just root 10. And then tangent is going to be 3 over 1, which is 3. And then the reciprocal is 1/3. We're then going to see if there's anything that can rationalize. So we can see that this first one we can rationalize to be 3 root 10 over 10. And then the second, for cosine, we can rationalize to be root 10 over 10. And then these would be my 6 trig ratios.
In the second example, it's very similar. So again, they tell you cotangent is 2 over 3. Right away, then I know tangent is the reciprocal, so that's 3 over 2. And then now we're going to go ahead and draw a right triangle. So I have a right triangle here. I'm calling this theta. This is my hypotenuse. This is my opposite. This is my adjacent. And you can use that you know cotangent is adjacent over opposite, or if you know that if you're more comfortable knowing tangent is opposite over adjacent, either one would help you get that the opposite is 3 and the adjacent is 2. We then have to do the same thing. We're going to find our hypotenuse this time. So I'm going to do 2 squared plus 3 squared is x squared. We get 13, and then we're going to take the square root, and we get radical 13. And then now we're going to go ahead and write all of our ratios. So sine is going to be 3 over opposite over hypotenuse. So 3 over radical 13. Cosecant will be the reciprocal, so root 13 over 3. Cosine will be 2 over radical 13. And then secant will be the reciprocal, root 13 over 2. And then finally, I'm going to check which ones I have to rationalize. And we have to rationalize sine and cosine. So when I rationalize these out, we would get 3 root 13 over 13. And 2 root 13 over 13. And those would be my final answers. The next topic we're going to look at is evaluating angles and specifically using our special right triangles. So if we think of our special right triangles, we know sine, cosine, and tangent. We can derive from that. If I have my 30, 60, 90, we typically have been using our ratio of 2k, k radical 3, and k. I can leave it like that. I can put a value in for k if I really want to, but we're looking to find the sine of 30 degrees. So it doesn't matter what type of angle we're looking at, or what the side lengths are, they're going to reduce to be the same answer. So you can use the k's. You can also rewrite it without the k's and just leave the ratios there. So I could make this a 2, a 60, a 30. This is like a 1 in front and a radical 3. So with these problems, when we're doing the ratio, you can use the k's if you like. They're just going to cancel out. So if you'd rather do it without the k's in there, that's fine too. And I'm going to find the sine of 30 degrees. So sine would be my opposite over my hypotenuse. So sine of 30 is going to be 1 over 2. And again, typically with these, we don't want to just put them in our calculator. We would like exact answers for these ones. If I had kept the k's just to show you, if I did sine of 30 and did it with the k's involved, you would have had 1k over 2k, which still would have been 1/2. So you would have gotten the same answer either way. For the next two, they're kind of the same concept. So with the 45, 45, 90, because this is tangent of 45, I had it as k root 2. If you don't want to write the k's and just want to write the coefficients in front, you can do that. Like we saw in the last example, both will get you the same exact answer. So we're looking for tangent of 45 degrees. I can choose any 45 degrees I want. They both are going to get me the same answer. So tangent of 45 we see is 1 over 1, or 1k over 1k, which would just be 1. So tangent of 45 would just be 1. For the last one, we have cotangent. So you can do this a couple of different ways. So we have cotangent of 60 degrees. I'm going to do 60 degrees, my 30, 60, 90. And I'm just going to write without the k's. But again, if you want to put the k there, you'll get the same thing. And if we get stuck on what cotangent is, really what we can do is we can find tangent and just flip the problem when we're done. So tangent of 60, you can see that's my opposite, my adjacent. That's going to be root 3 over 1. So then we know cotangent is the reciprocal of that. And then at the very end, I'm going to see that I have to rationalize my answer. So I'm going to multiply top and bottom by radical 3. And we would get radical 3 over 3. And so that would be my final answer for cotangent of 60 would be radical 3 over 3.
If you have any questions, you can ask in class, sign up for T-Will time, or go to the center.